So you have 2 and then cube root of 5 comma. So this you are done already, isn't it? Meaning in the class they did it. Okay, so this is nothing but 2 5 to the power of 1 by 3. This is 2 into, and this is 3 into 2 to the power of 1 by 3. Correct? So because this 1 by 3 is there, you have to take cube root of both. Sorry, cube of both, not cube of both. Then when you do cube, you get 8 here and you get 5 here. Here you get 27 multiplied by 2. This is 40. This is 54. Right? Therefore this is less than this. You said the other way around. Okay. So that's the one. And how about, I think next one you will square it, right? 6 root 5. Okay. So you square it and then find it out. So that you can do, right? Do the question number 4. Yeah, that's the same 13th main or whatever, and the 4th question. Not the 13th main. We are doing this, right? This is what we did. Oh, this is the third one. Okay, I have the fourth one. I can give you the fourth one. In this book I have, so I can write the question for you. The question is 4 cube root of 4, 5 cube root of 3, and 3 cube root of 7. This 3 is at all. 3 cube root of 7. Compare. So this is the least one, and this is the greatest one. Okay. So you this is the greatest. Okay. So this is the greatest, and this is the least one. This is a middle. Okay. Fine. Now coming back to insert two irrational numbers between 5 and 6. So write in descending order. I am leaving it because that's simple. So insert two irrational numbers between 5 and 6. This teacher is it taught or not taught? You'll but then you have some idea or no idea? No idea. insert two irrational numbers, right? So how do we get an irrational number between 5 and 6? 5, for example, we have inserting two irrational between 5 and 6. Okay, so 5 is nothing but root 25. 6 is nothing but root 36. Correct? So these two are perfect squares. So you can insert anything now. For example, I can have root 26. I can have root 35. I can have root 29. All these are irrational, isn't it?
Yes, sir.
So that's a simpler way. The simplest way actually you can do that. Okay.
So everything from root 26 to root 35, you can, how many are the same values?
Yeah, you can pick any two. Any of those two, they are irrational. Yeah. Okay. How? Because we are going ahead with that what we talked the other day. So two types of irrational numbers. One is that the square root of not a perfect square, then automatically that one is an irrational number. So the next question, 17 or 16, I don't know. Wait, let me see what question is this. Next question is uh, 17, right? 17th question. Insert 5 irrational numbers between 2 root 5 and 3 root 3. Yeah, 17th question. Yeah, same thing. So can you do or you can't do? Huh? Yeah, try. Yeah. Between 2 root 5 and 3 root 3. Okay, so you got root 21, root 22, and root 23, and root 24, root 26. Okay, so you can actually simplify this. Write this as a, how much you can write? It's a 4 6, right? So 2 root 6. 2 root 6 you can write it, and other things you can leave it like that. Okay, so because after you insert you need to be simplifying it, and that's why that's the right answer. Try then 18th, right? Two rational numbers. In a 17th one, where? Yeah, of course. Of course, this is irrational. It's irrational, right? Uh, uh, yeah. 18th one. Write two rational numbers between root 2 and root 3. He wants a rational number. Okay. So between root 2 and root 3. You're not getting. Why? Okay. 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 You square, you will get 2 only. You square, you get 3 only. That's how we are thinking, and so we don't get anything. Right? So let's suppose I multiply this by 100. Okay. So now I try to get a square numbers between these two. So beyond 200, what is the closest square I have? 12 square is 144, 13 square 169, like that. 14 square 196, 15 square is 225. Okay, what is the next square? 16 square 256. What's the next square? 289. Right, 17 square 289. Because we multiplied by 100, so divide these fellows by 100, or everything by 100. Divide by everything by 100. Right? So you are dividing by 100 now. So you will get 2 comma 2.25, right? 2.25 comma 2.56 comma 2.89, and of course 3. Because we took a square, right? So you have to take a square root of everything now. So this is as is, whatever is there you will have that. This is obviously square root of 1.5 because it's, so this is 1.6 and this is 1.7. So did he ask 3 numbers only? He asked only 2, but we did 3. Is 1.6 correct, or it's a perfect square? No, right? It is not perfect square. No, no, 0.4 multiplied by 0.4, 16. Okay, so this is not, I mean, it looks as if it is, but it is not. Okay, this is all are irrational only. Okay, so try the next question, 19th one. Oh, I'm sorry. The square root of 2.25 is 1.5. Yeah, I think you're right. Yeah, you're right. I put that square roots. So that's 1.5. That's 1.6. I'm thinking differently. So 1.7. You're right. 1.7. So this is the answer for that. Next question. So he wants 3 rational numbers, right? Are we going ahead in a similar way?
Yes, I got
You-
1.8, 1.9,
So 1.8, 1.9, and So appear to be correct because you have taken, you squared it, you got 3. Oh, 18, 19 and 20. Yeah. So you went with the 300 same method, isn't it? Okay, this is correct. Yeah, this is correct. Okay, so 20th question. Simplify each of the following. Looks like you have done each and every question. It's done. It's finished. Okay. So now going to the next part, representation of rational irrational numbers on a number line. Rational numbers was easy. That's almost covered. Okay. So irrational numbers on number line. So here, so for example, the first thing what we want to represent is root 2. So we want to represent root 2. Okay. So draw the number line. And if you want to scale, then use the scale here. So I'm using the ruler here. So let's mark on that. Okay. So assume it's not straight line, but it is a little angle, but that's fine. Okay. So we'll take 0 here, and from there we need to have a 1. So that's why I'll just take this and assume that this is, so approximately somewhere here. So somewhere here, that's a 1. Okay. So if you draw to the scale, that means if I say 5 centimeters is 1 unit on this, okay, because we want to represent in a big way. So what I mean, to show a bigger picture, so what I will do is approximately, okay, I'll better draw a line itself and I'll ignore that line. Okay, so I'll just take this line and okay. So I mark a 10 and I take 15, right? 15 is the, I assume that as a 1 point. Okay. So this, if this is a 1 unit, at this point, okay, I would like to draw perpendicular at this point. We call this as O and we call this as a. So we have to construct a 90 degrees line here. So you know the construction, how do you do that? No, you are actually, this is 180 degrees, right? You are doing the angle bisector. Yeah, from here you take like that, correct? Okay, so yeah, you got middle. So you got this as angle bisector for that 180 degrees, and on this you mark exactly the same thing. Okay, so on this it's a 1, exactly this much, right? So you are taking, for example, 1. Okay, so So it's 10, so it's 5, so approximately this is the one. That's not 90 degrees because I have not drawn 90 degrees. Okay, you can draw it here. Okay, I just don't want to spend so much time on that. Okay, so take this out. So this is at 1 centimeter line, and so this is the 1 centimeter line, and you mark this into this. So come from here. I told right. It's scale. Yeah, one. We take that 5 centimeter, but we consider it as 1 unit. We scaled it up, right? So that's why this is also 1 unit. You can say. But in reality, it could be anything, 1 centimeter or 1 kilometer, no problems. Okay, this is 1 unit, just 1 unit. So you got this is a 90 degrees and 1 unit. So by Pythagoras, this is root 2. 1 square plus 1 square is root 2. Okay, but this is not on the number line, right? It is there. It is diagonally there. So from here, take this as a OB as a radius. Take OB as radius and O as a center. So O as a center, draw the arc now. Okay, so if you draw the arc from here, so it will come somewhere onto this. So this is C. So this point OC represents row 2. This is given in the textbook. Okay, so now from here onwards you have to go step by step. What do I mean by step by step? So after getting root 2, the next irrational number is root 3. So for that you take OB as a base and draw 90 degree. I'm coming. Which is not on the number line? OC is already put on the number line, right? OB is not on the number line. Yeah, correct. OB is not on the number line. I'm going to the next page. Okay. So in the next page, so we already have, okay, so we already have, for example, this O and this is C. Okay, this represents root 2. Correct. Somewhere here was OA, and we represented OC already as a root 2. Understood, no? OC we already had root 2. OB as root 2, and then we had taken a arc. Yeah, see, this point is root 2. This point is root 2. OC is root 2. OC is root 2. Okay. Now, since you asked the question, B was not on the number line, C is on the number line now, right? So you can draw the vertical here, but only 1 unit. So this is 90 degrees. You make this as a 1 unit. This is 1 unit. This is root 2 units. Okay. So join D. So now OD is 2 plus 1, right, by Pythagoras theorem. OD is root 3. This is root 3. So again, this is not on the number line. So what we do, we take a, with OD as a radius. Exactly. Well, OD as radius. Cut an arc OE along OC on number line. Yeah. So that exactly correct. You have to go incrementally actually. So for example, yes. So OE represents now OE is root 3. So now next question was, you said 3 plus 1 should I go 3 plus 1, okay, and then I get 4, and then take square root of 4, that I get 2, okay, or and then square root of 4 you take it as a total unit, okay, and root 4 square plus root 1 square, you will have a root 5. That way you can do. Or this is a root 3 point, right? Then here you have a root 2 point. From here you can take root 2 units. That's the other method. This is root 2 units. This is a total root 3 units. So when you square, you will have 3 plus 2, 5. That way also you can do. This is for 5. Yeah, you can continue. Yeah, I did it for 5. This is root 5. Yeah, you can continue that. Yeah. So OF is root 5. Then with the OF as a radius, you put on number line here. Continue that. Okay. So this is the arc, right? So with this arc, you will get this point. Okay. Like that we continue. So that is how we represent them on a number line. Yeah. So this is representing the points. These are all, since we mark this as a 0, right? Everything is like, for example, OC is nothing but 0 plus root 2. Correct, right? OE is 0 plus root 3. And whatever you take, for example, that's a OG. OG would be 0 plus root 5. So what if we want 1 plus root 2? Let's suppose we have a question. I would need to represent 1 plus root 2. Or, yeah, I need to represent 1 minus root 2. First of all, whether there is a minus root 2's possible, right? Definitely can have. Okay. Yeah. So 1 plus root 2, you start from 1. Do the same thing. Start from 1, construct the same thing, but measure from 0. I am writing. Okay, measure from 0. See, we have a line, and that's a line. Let's suppose we have 0, and somewhere here you have 1 already marked. From 1 you do the construction. So this is that 1 unit, and from here you have a right angle, and then you join them. Then this becomes root 2, right? So you have taken an arc. So you got this point. This is a root 2 point. From 1. From 1 this is root 2. So if you want 1 plus root 2, from here if you measure, up to this is 1, and from here it is root 2. So this is 1 plus root 2. Got it, right? Yeah. 0 has to be there. So same way you can do whichever number, 2 plus root 2 or 2 plus root 5, 3 plus root 5, anything you can do, right? So you said this is what they will cover later in school, maybe tomorrow. Oh, yeah, you said yes, there is a problem with the constructions and things like that. Yeah, I just forgot that. Okay, now we then go to, you see, 1C, exercise 1C. I think the first question, you sent it, right? You sent that to me. But that's 1D, right? Oh, okay. So state which of the following are certs which are not. And then what's the next question? Find the lowest rationalizing factor. Yeah, yeah, yeah. So I think we will do now the second question. The first question is easy. I saw you marked already. No, you didn't mark. No, the first question. No, we didn't. You didn't start. Okay. So first one is square root of 180. Is that the question? Okay. Uh, so let's go identifying certs. Two root. Yeah. 2 root 3 is how much? Let's go back. So exactly. 2 root 3 is root 12, isn't it? Root 12. I mean, I'm taking 2 to inside this. Both same. Both same. You know, you square it, you'll get 3, 4, 12. Root 12 you need to be representing. Okay. So how do you want to represent root 12? So you have, for example, root 5 already, and you have root 7. Okay. So root 5 square plus root 7 square. Then you have 5 plus 7, which is 12. Correct, no? Yes, you have to go from the beginning. Yeah. You, no, 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 no. I think I'll do that next. I mean, I'll help you on that. So, let's erase this. So we thought it's you have 2 root 3, and we said this is equivalent to square root of 12, and we want to know this is root 5 squared plus root 7 squared. So definitely you need a root 7 and a root 5. Correct, right? So we have gone to the number line. So this is starting with a 0. So you have assumed this is 1 unit. So with 1 unit you have constructed here the perpendicular. So this is a 90 degrees line. So you have got the root 2 here. So you cut the arc. So this is a root 2 point. Okay. So with the root 2 point we need 7 and we need 5. So you construct from here to here, you get 4. Am I right? So is that what you are talking about doing from the beginning? No, for root 5, right? You have other method. Huh, 4 plus 1, right? 4 plus 1. So you have this is a 2. This is 2. And here you have a 1, exact 1, right? This is 1. And now you join this. Okay, this is 90 degrees. So this one is nothing but root 5. Correct, no? 2 squared plus 1, 4 plus 1. That's 5. So you got the root 5 like that. This is a root 5 point. Okay. Then whatever is this length, you measure exactly this point you already have. Okay, let me call this as a OA. At this point you put OA. The length here would be OA. So that's basically root 2. Okay, then you have root 7. So when you join, you have a root 7 coming from here. So this is a root 7 point. So you have this coming. This is a root 7 point. So at root 7, have exactly the root 5. Okay, so I'll put as a C. Okay, so root 7 point, at that root 7, you go further up. That may be the root 5. So you join this. Okay, so whatever you get is the 5 plus 10, which is 12. Yeah, so this is your root 12 point. Understood? Okay, so with that we can go to the so we're talking the next point, right? Search and identifying. Yeah. So first question was root 180. So you can probably write this as 9 times 2 times 10, or correct, 10. So basically you have 9 times 4 times, sorry, 9 times 2 into 2, 4 times 5. So you got 3 and 2. So you got 6 root 5. So this is definitely rational, and therefore you have this in a surd form. Second question is 27 to the power of 1 by 4. Definitely, right? You don't have a perfect fourth root for 27. So it's a surd. On the other hand, if I have 81, 1 by 4, not a surd. Yeah, 27, 1 by 3, not a surd. Okay, so the next is 128, fifth root of 128, surd. Third root of 64. Yeah, not a surd. Yes, good. And cube root of 25 multiplied by cube root of 40. So yeah, multiply these two first. You'll get 1000 cube root. That's a 10. So not a surd. Okay. The next one, cube root of minus 125. Why? Minus 125 cube root. Yes, good. That's correct. The next one, root pi. Is a surd or not a surd? Because pi is irrational. So you take pi squared. Okay, let's check the answer in 1D. What's the answer he has given? You can also see, because I'm just wondering what answer he has given for seventh one. Not a third. Yeah, because you're, yeah, huh, you can't have irrational under square. See, whereas root 2 is a third, because this 2 is rational. Understood, right? That's the condition. That's why I got doubt. As I wanted to check. Uh, huh. Correct. Correct. Okay. Because of that, it is not third. Okay. Then the next one, same. Not a third. Root of 3 plus root 2. Not a third. The next one is also not a third. Oh, you don't have that. Okay. Yeah. Then next question is write the lowest rationalizing factor. Is that the question? Next question? So first starts with 5 root 2, right? So what is the lowest thing I can make it as a rational? Is it a root 2? And this becomes 10. Okay. Then for root 24, you don't know. So let me see. If I say root 6, so let's try with the, he's saying find the lowest rationalizing factor of this. Can I do root 2, or can I do root 3, or can I do root 5, root 6? Let's look at this way. If I do with the 2, then I get root 48. Root 48 is 3, 4 root 3. Correct? It's a 4 root 3. So it doesn't work for root 2. So if you look at, then you have root 72. That is nothing but 6 root 2. So this also doesn't help. Correct? Root 5, then I get root of 120. Okay, so this also is not a rational number. Okay, now let's say root 6. So 24 6 are 144. So square root of 144, I'll get 12. So root 6 is what I am thinking. Is that the correct answer? Textbook answer? Check the textbook answer. Root 6. Good. So what are the other questions you have in the textbook? Hmm. Hmm. Okay, so let's do root 5 minus 3. The next question immediately. Okay, so you have root 5 minus 3. So what is the lowest rationalizing factor? Can I blindly say, is this the lowest one? Just change the sign and multiply. I get 5 minus 9, which is minus 4. Can I say that? Okay. So when they say factor, obviously has something we need to be multiplying this with that. Okay. That's why. So the next question would be again 7 plus root 7. And for root 18 minus root 50, uh, so root 18 can be taken as 3 root 2 and root 50 is 5 root 2. Got it? So you have minus 2 root 2. So the answer is this. Yes, yes, correct, correct. So because the other things we can't simplify, you have just taken the sign change and multiplied it. Okay. So where else? Next question. Then the rationalize the denominators. Third one that we have covered. Now let's look at fourth question. Find the values of a and b for each of the following. Can you do the first one? Yeah, it's easy. Actually, you have done half of the part yesterday. I mean, day before yesterday. Yeah.
It's 7 A plus B will be 7 plus
A plus b.
A is 7 and B is 4.
So a is 7, b equal to 4. So you are done 2 plus root 3, so you got minus 1, and 2 plus root 3 whole square, that's 4 plus 3 is 7 plus 4 root 3 divided by minus 1, right?
Plus
4 minus 3, which is plus 1, correct. So 7 and 4, right. 7 4 is correct. Try the sixth one. Do you have sixth one or four? Only four. Only four. So do the fourth one. We'll complete this exercise today.
Sir, A is 43 and B is 50.
A is 43. B is. Question is on 5 plus 3 root 2. Is that the question? Hello? Oh, yeah. Is 5 plus 3 root 2. Is that the question? I can't hear
Sir, I
you.
can't hear you.
Yeah, yeah.
A is
Yeah.
A is 43, B is 50.
No, which is the question? Is the 5 plus 3 root 2 divided by 5 minus 3 root 2? Is that the question? Hmm? So 25, 25 plus 18, so 43. Yeah. Again, you are not able to hear me. Hello, you can hear me. Okay. So you got the textbook answer? Hmm. Yeah, 43 by 7 is correct. No, no, no. You have to take that 7 also, right? The whatever is coming in the denominator. Understood? Understood or shall I do? You got it. Okay. Yeah, yeah, yeah. Obviously. So then there is fifth main. Simplify. Simplify. I'll do one question or you will be able to do. You will try. Okay. Or I will do the. Is the last question is 18 by 3 root 2 or something? Two questions. So root 2 by root 6 minus. That's the one. So I'll do that. Okay. Root 2 divided by root 6 minus root 2 minus root 3 divided by root 6 plus root 2. This is much easy. So you take in a normal way LCM, which means you multiply these two. This is a squared minus b squared. So you got 6 minus 2. Then you got root 12. Then plus 2. Then you got, sorry, 6 minus 2. This is 6 minus 2, right? 6 minus 2. Yeah. So root 12 and then this is 2. So you got root 18 minus root 6. So this is, are you getting 4, right? This is 2 root 3 and this is 3 root 2 minus 3 root 2 and this is root 2 root 3. So this will be root 6 only. So nothing will work out there. 6 minus 2 divided by it's a 4 you are getting. So on the numerator you can't simplify any further. Minus root 6 minus root 6. So 2 root 3 minus 3 root 2 minus root 6 is root 2 into root 3. 2 minus root 2. Yes, I suppose that's all you can do. Root 6 and root 18, root 16, root 6 and yeah. So try now first question. Whatever you have. 22 by 2 root 3 plus 1. Yeah. Yeah, you have 4 terms here, no? I still haven't written the 2 here. This fellow I have not written. I have not written that. Yeah, it's the same because I am saying you can't simplify that further. Yeah, you can't simplify. That's it. Yeah. So do the first question. Plus root 6. Oh yeah, minus plus root 6. You're right. Yeah, plus root 6. Yeah, this is minus, right? Yes, correct. 5 by 11. So you want to verify with the book or already verified? Check. So I am starting now. I am writing it. So clearly this a plus b, a minus b, the denominator is easy. So the denominator you have, this square is 4 3s are 12, 12 minus 1. Is that correct? Yeah, 12 minus 1, which is 11. So now here 44 root 3 minus 22 plus 34 root 3 plus 17. Like the mistake I did last time. Okay. So 44 plus 34 is 78 and minus 5. So divided by 11. Yeah, yeah, that's actually 78 root 3. So this question is done. Then the sixth one is x and y are given. You need to find x square, y square, xy. Is that the question? Okay. Yeah. So you want me to do or you'll try? Okay. First one x square, is it? Okay, let me do it. Don't check the answer. Let's do it. Root 5 plus 2. So you want x square. X square will be whole square of this. Okay. So you want to directly square it. You can do that way also. You'll have 5 plus 4 minus 4 root 5 divided by 5 plus 4 plus 4 root 5. That's equal to 9 minus 4 root 5 divided by 9 plus 4 root 5. So you rationalize. Sorry? Yeah, I know you. So this is one way you can do this way. Okay. So when you do this way, then you have 81 and plus 16 fives are 80. Then you have minus 9 fours are 36, 72 root 5 divided by, and this is 81 minus 80. So you got 161 minus 72 root 5. So you can do the other way also. What is the other way? First rationalize x. Rationalize the denominator of x. Then square it. That means root 5 minus 2 whole squared divided by, you will have 5 minus 4, which is 1. So you are doing square this and then do one more square. Got it, right? Square is already 9 minus 4 root 5. So if you do 9 minus, you didn't understand this. You didn't understand this. Okay. So let me erase this and then I will come to that part. Okay. So x is root 5 minus 2 divided by root 5 plus 2. Rationalize this first. So you'll have root 5 minus 2 divided by root 5 plus 2. That is nothing but root 5 minus 2 whole squared divided by 5 minus 4. Correct? Rationalizing. This one minus. This is minus. This is minus. So you got 5 minus 4 is 1. So root 5 minus 2 whole square is 5 plus 4 minus 4 root 5. This is 9 minus 4 root 5. So this is the x. So x is 9 minus 4 root 5. Now x square equal to 81, right? Plus 80 minus 72 root 5. You will get the same thing. Yeah. So you can do that way also, you can do this way also. So now try y squared.
So
161 plus 72 root 5. See, it's like, because x equal to 1 by y, correct, right? The observation is that x equal to 1 by y, or so it has to be 1 by x square. So third one is easy, xy, right, equal to 1. So now you have x square and you got y square, add them plus 1. That means this negative thing goes off. So you'll have 160, 160, 322, 323. Oh, you don't have that. You don't have that x square plus y square xy. Yeah. So you have the first one x square, second one y square. Add it up, you get that. So yeah. So the next seventh question, x. If you look at that 1 by x, right? That means 1 by 5 minus 4 root 6. Yeah, seventh one. M is equal to that one. M equal to 1 by 3 minus root 8 or root 2. Hmm. Yeah, same root. Yeah, correct. And then ask you to find out m square and n square. Yeah, that you take it as homework. Any more questions? Is it the last question? Till 15. Wow, I only have 10 here. Okay. So I think you sent it, no? You sent 1D. Okay, okay. Then never mind. Then never mind. What, you don't need to rush actually. So you do that eighth question, m square. Ah, sorry, the seventh question in your book, seventh question. You do the first part, then we will stop. Okay. If you can complete all the three, fine. If you can't complete, then we will stop and we'll continue Tuesday. Okay. Hmm. Start 1 by 3 minus 2 root 2.
So it's 1 by 17 minus 22.
M square is it? How am I doing correct or?
No, so I will do that. I did 9 plus 8 minus 2 into 5 to the power 2.
So
Then minus 17 minus
17 minus
10 root 2.
10 root 2 is the answer. What you got?
Yes, sir.
That's m square.
Yes, sir. That's correct.
So m is this. I'm doing m squared. 9 plus 188 is 12 root 2. How did you do?
Here I do 1 by 3 minus 2 root 2 again, and then whole square. So 1 square is 1, and then a square plus b square minus 2ab. So 3 square plus 2 root 2 whole square minus 2 into 3.
Oh, okay. So you are saying that you got 1 divided by 17 minus 12 root 2. That's what you are saying. Okay. Okay, good question. I mean, good. But then eventually, right, you have to convert into, you have to rationalize the denominator. Yeah, that's, uh, uh,
17 plus 12.
yeah. So it will become this only.
Yes, sir.
Okay. So n square, a similar one.
17 minus
Yeah,
12.
correct. And mn is easiest.
1.
Yeah,
No, yes, 1.
this one. It's correct, one. Because 1 by 1 you will get it's 1. Okay.
Yes, sir.
Hmm. What's the next question?
If x is equal to a comma, if x is equal to 2 root 3 plus 2 root 2, find 1 by n, x
Hmm.
plus 1 by n, and x plus 1 by 2.
Yeah, I have that same thing. So you do for like straight away third one. Yeah, third. No, yeah, eighth main third.
825 plus 386 root 6 by 20 plus 8 root 6.
Hmm. What is that? So you want to check the answer? Something different. Even I also got something different. 93 plus 30 root 6 divided by 4. Yeah, somewhere we have done mistake here, right? So 1 by x I did is nothing but 1 by 2 root 3 plus, oh, oh gosh, I made a mistake. I got 2, huh? I think I did a mistake here because of 3 root 2. I think I'll get the answer now. This is 2 root 2. So this is 2 root 2. So let's erase this and do it nicely, that part only. So then I think entire thing you can erase. So you didn't get the answer, right? So I am doing this 2 root 2 and 2 root 2. So then I get, this is 4 3s are 12 minus 4 2s are 8. That's what is the denominator here. So you get 2 root 3 minus 3 root 2. Again I am doing mistake. 2 root 2. This is 2 root 2. So 12 minus 8 is 4. That means we got root 3 by 2 minus 2 by 4. It's 1 by 2 root 2. So this is 1 by x. So 2 minus, so you are doing x plus 1 by x. So you will get, this is 1 by x and that is x. So when you do x plus 1 by x, 2 plus half is 2 and half. 5 by 2 root 3 and 2 minus half is 3 by 2 root 2. Got it? Or doubts? You got that? Yeah. So now squaring this. When you square that, a square is 25 by 4 into 3. 75 by 4. Plus 9 by 4 into 2. 18 by 4. So you are getting 93. Okay. Yeah, plus 2. So 15 by 2. Okay. So root 6. You got 15 by 4 or 15? 2. This is correct only. So if you take as a 4, then 2 here and 2 here. So 30 root 6. 93 plus 30 root 6 divided by 4. Okay. So we are done for the today. I will send this file. Okay, I'll upload it. Okay, you can use it for, this is a single file. Okay, so you can use it. Okay, any questions, any doubts? No. Okay then, right, I'm stopping the